Hi everybody, thanks for tuning in for another edition of Chem Talks. Mr. J here. Today we are going to continue our discussion of acids and bases by looking at what happens when you mix an acid and base, what kind of reaction you get, and being able to use that knowledge to make some predictions. So as we go along, as always, please take some good notes, and if there's anything you're not sure about, either put a question mark in your notes or write it yourself a little note to ask the question in class, and we'll go over it. All right, when we mix an acid and base, we get what is called a neutralization reaction. And in a neutralization reaction, what we see is the resulting mixture that we get is not as acidic as the acid started with, or not as basic as the base started with. They are neutralizing each other. Think about what we mean by neutral. Neutral pH is 7, right? So when we mix an acid or base, the overall solution of the or overall pH of the solution is moving towards that neutral pH 7. It may not get exactly there, but it's moving towards it. So we call them a neutralization reaction. Now remember we talked about Bronsted-Lowry acids. Bronsted-Lowry acids and bases said that an acid is anything that donates a proton, and a base is anything that accepts it. So in any reaction, acid-bases reactions aren't any exception. What we see is that one bond is broken and another bond is formed. And what we're looking at in this is that we're seeing a hydrogen removed when a bond breaks, and then it's going to form when it attaches on the other side. Okay? And so what we see in the Bronsted-Lowry acid-base reaction results in the transfer of a proton, which is the hydrogen ion. Why do we call hydrogen ion proton? Think about hydrogen, right? It's made up of one proton, one electron. When it becomes an ion, it loses that electron, so all we're left with is a single proton. So our proton is represented by H+. Okay, so what we see is that in a Bronsted-Lowry acid, the reaction results in the transfer of a proton from the acid to the base. So let's take a look at this example. NH3, remember, that's our one base that we've been talking about that doesn't have hydroxide in it. So in here, if we look at, just looking at them, okay, we can probably predict that this is going to be our acid. Remember we said acids generally start with H, and bases are going to have hydroxide. Well, this is our exception, as we said. So let's look over at the other side. What's happening here? We said water is probably going to act as a base. If we go to water, or what's left of water, we see it lost a hydrogen. And that's our definition of an acid. It's donating a proton, or in this case, donating the H+. The ammonia, NH3, becomes ammonium because it gained that hydrogen ion that water lost. So OH here is the result of losing the hydrogen. So H2O is acting as our acid. And then over here, we gained the hydrogen. We know we gained it because there's 4 hydrogens there. Also, we have the plus there. So our NH3 is our base. On the other side, what we're going to call these is they have new names once they gain or lose acid. And we can call them either a conjugate acid or conjugate base. And we're going to talk about this on the next slide. Okay, so conjugate pairs. A conjugate acid is the species. Remember, species is anything that's involved in a chemical reaction. It's a species formed by the reception of a proton or hydrogen ion, okay, by a base. So in other words, it's a base with a hydrogen ion added to it. A conjugate base, on the other hand, is what's left over when the acid donates or loses that hydrogen ion. Okay? So it's a species that's formed by the removal of the proton from an acid. So an acid plus and a base will give you a conjugate base and a conjugate acid. Remember, the conjugate acid is what's left when the acid loses a base, and conjugate base is what's formed when it gains a hydrogen ion. Let's look at a couple examples of this. Okay, in this reaction, we have HNO2 plus water. They give us nitrate, and this is the hydronium ion. So let's look what HNO2 is doing. It comes NO2 minus, so it is losing, or it's giving up its hydrogen ion. Okay, H2O water is going to gain that hydrogen ion that was given up there. So we can name these. We can say, here's our acid, it's giving it up. Our base is going to accept it. Okay, what's left when the acid gives up its hydrogen is a conjugate base. And then here was our base. It's going to gain a hydrogen, so that's how we know it's base. And then when it gains it over here, now we have an extra hydrogen, so we call it a conjugate acid. Let's look at one more here. See if you can figure out who in this one is the acid and base and who's the conjugate. So go ahead and pause it, write that down, and then come back with me. All right, look at this. NH3 is going to NH4. How did it get there? It gained a hydrogen ion, or a proton. We can look at it that way. Water, on the other hand, is going to donate one. Okay, we remove it. Now in the last one, H2O went to the hydronium, H3O+. So water is kind of interesting in that it can act as either an acid or a base. In this case, it's acting as an acid because it's losing one. And the last one would act as a base as it gains one. So here's our base because we're gaining hydrogen. This is going to lose a hydrogen, so it comes our acid. Okay, what's left when we lose hydrogen is our conjugate base over here. And then when a base gains the hydrogen ion, we call it the conjugate acid. So just got to look at where the hydrogen is traveling to figure out who's the acid and base, and then who becomes a conjugate acid and base. All right, as we said earlier, a reaction between an acid and a base is a neutralization reaction. What do we mean by neutralization? Well, we're neutralizing the pH. We're moving towards that neutral at 7. The resulting solution is not going to be as acidic, meaning not have as high as pH, or lowest pH, excuse me, as we started with, and it's not going to be as basic, having as high as pH. It's moving towards that 7 mark. Okay, so look at this reaction between hydrochloric acid and sodium hydroxide. Hopefully you recognize that hydrochloric acid, HCl, is a strong acid, and sodium hydroxide is a strong base. What does that mean, remember? It means that when they're put in solution, they're going to 100% dissociate. Meaning if we had 100 particles of hydrochloric acid, it's going to break down to 100 H plus ions and 100 Cl. So they fully break apart, in opposite of what we talked about when we talked about weak acid and base. Remember, they don't dissociate. So when we have a reaction between an acid and base, what we're going to see is that we get two products always. First one is going to be a salt, and then we are going to get a liquid. Well, where's the salt come from? Well, it's going to come from the cation on the base and the anion on the acid. And remember, sodium chloride, it's table salt. We think of that all the time. But remember, a salt is simply an ionic compound, so it could be something other than sodium chloride. We're going to form some sort of generic salt and water. Okay, why is this not aqueous? Because it's water. Nothing's dissolved in it. It's H2O. Okay, so whenever we mix an acid and a base, we end up with some salt and water. So here's our acid base. We're taking sodium hydroxide plus hydrochloric acid, and we get our water here and sodium chloride. So just a little visual for you there. All right, let's look at, take an example here. For the acid-base neutralization of HNO3, what's that? Remember our naming, it's nitric acid, and calcium hydroxide. Write the balanced formula equation, or the molecular equation, the complete ion equation, and the net ion equation. So going back to what we did earlier in this unit. So let's go ahead and do this first one together. And so we know that we're going to combine HNO3 plus calcium hydroxide, and what's going to be our two products? We're going to have a salt and a water. So H and OH are going to form our water, and then our salt's going to be calcium and NO3. Okay, so remember, calcium has a +2 charge, NO3 is a -1, so I'll take that into consideration. So here is the reactants of it, and our salt, as we said, is going to be calcium nitrate and water. Now, if we look at this, we got to see if we're balanced. So 1 H here, 2 H's there, so we got 3 on this side, 2 on that side. So obviously we're not going to be balanced, so we're going to have to balance them out to begin with. So if we put 2 H's here, now I have 2 H's plus 2 H's. That gives me 4 H's there. Oops, I only have 2 over here, so I got to put a 2 over there. Okay, my H is balanced. Let's see, NO3, I have 2 here. Now I have 2 NO3s here. I have 1 Ca, 1 Ca, 2 O's, and 2 O's there. So we are balanced. So that's our complete balance equation. Now or complete molecular. Now we need to write the complete ionic equation. So remember, when we're writing the ionic equation, anything that's not a solid or a liquid will disassociate. Okay, so we're going to break this apart, this apart, this apart, but we're going to leave the water. Okay. The other thing to remember is, what do we do with subscripts and coefficients? Well, our subscript here now becomes a coefficient on the hydroxide. Okay, we have 2 HNO3, so that 2 is going to go with the H and the NO3. And then once again, we have a coefficient or subscript here that's going to stick with your NO3. It doesn't affect the calcium. Okay? And then the water, since it's a liquid, is going to stay in that form. So that's below is our complete net ion equation. All right, now we have to write the net ionic. And remember, net ionic involves getting rid of what's not changing. So if we look what's on the same as the reactants and products, first thing I notice is that I have calcium on both sides. So we can ignore that. And then what else? Looks like I have 2 NO3 there, 2 NO3s there. They're going to cancel each other out. So what that leaves me with is some hydroxide plus water to give 2 H2O. So our net ionic equation is this. And what we're going to see is this ends up being our net ionic equation in all neutralization, right? We're forming water. All right, let me have you try this one on your own. Go ahead and pause the video now and see if you can write the complete balanced molecular formula, the complete net ionic, or complete ionic, and then the net ionic equation for this. So pause this, and once you have it done, come back. All right, hopefully you've done this and aren't cheating. If you are cheating, stop and do it. Okay? So here is our balanced formula. We have hydrochloric acid plus sodium hydroxide. We're going to get NaCl out and H2O. We saw that in our earlier example. Now let's look at the complete ionic. So everything that's not liquid or solid is going to blow apart. Okay, luckily we have no subscripts to worry about or no coefficients, so it becomes pretty easy. Okay, now what we got to do is find out what's the same on each side. So I'm going to look at the right side here. I got Cl. Oh, I got Cl over there. I got Na here, Na. So that leaves me with hydrogen plus hydroxide to give water. Look at that. Amazingly, the same net ionic that we had last time. All right, let me have you try one last problem on your own. For the acid-base neutralization of perchloric acid and potassium hydroxide, go ahead and write the 3 different formulas. This is the last one we'll do today. So pause it, write them, and then come check yourself. All right, look at our complete balanced molecular formula. Okay, we have perchloric acid plus potassium hydroxide. Okay, our solid here is potassium chlorate and water. So once again, we got lucky, no subscripts. So when we write our complete net ionic, everything just kind of blows apart this way. Now for the net ionic, what's the same? Well, we should be able to know that we're going to end up with water again. But look at here, we got chlorate here, they're going to cancel out. Potassium here, they cancel out, leaving with hydrogen plus hydroxide to give us water. Okay, so here's our net ionic there. All right, guys, hopefully this was pretty easy for you. If you have any questions, please stop in and talk to me in class. If not, I will see you in our next class. Take care.